Welcome to a new test and teardown video. This is a tele-equipment oscilloscope type D1011. So it's a 2-channel analog oscilloscope, and this one is using Tektronix style knobs. Definitely look alike. Everything looks a little bit like that, right? With the centered CRT and the way they got now a beam finder and the on-off switch, and I mean there's definitely a lot of that. There's another really funny thing about this one. Look at the handle here in the middle, and then it reaches like that. Weird. And then you grab it like that, and there's a nice good balance. But then this frame here around the CRT needs to be wide and stiff and stable to be able to carry the weight like that. So it is a little bit special. You don't see any connectors at the front, and that is because they put them on the side. So channel 1, 2 inputs on the left, and then what is that? Trigger input on the right, and the calibration right there. So that means when you have this scope somewhere, you need now a lot of free space to your left and to your right. So, I don't know. I really don't like it to begin with. We will see what I like a little bit later. It also looks a little bit rusty. I can maybe clean this and fix this. Also, the knobs, as you can see here, not the cleanest. And down here is a little bit of nasty. It looks like it can easily be cleaned. And here is the back. Trace rotate, astics on something to do with how focus is all over the screen, by the way. And set modulation, some heat sink for the power supply. And I see all the screws in this cabinet on the front and top and all that quite rusty. So I am already a little bit nervous. What are we going to see? And in the bottom, this is where you find the voltage selection. So somehow you can probably get in here somehow. I haven't yet figured that out. Maybe we got some screws missing. It looks like that, right? Okay, so I was right about this with the screws. I think this plastic casting or something like that is mirrored somehow, so they're using the same plastic. How about that? I mean, here's this screw right here, right? And it goes straight through. But at the bottom, see, there's the same hole and everything here from the bottom, but it's not going anywhere because there is a melted in thread thingy in there, but that is the only difference. And then you have the top and the bottom part here in the middle. That is of course again the same, so you can use the same part of plastic or something like that, just the other way around or some, I don't know. Weird, isn't it? How is that possible? So now we're inside, and it's quite beautiful with the centered CRT and the input here and the sweep and the power stuff on the right side. I kind of like the way this is made, and you can actually take away both of these halves and pull out everything here and do service on each side. So it's very service friendly. Easy to find the fuse, and this is of course the high voltage transformer, And I already see a little bit I do not like, and that will be some of the high voltage capacitors actually touching the metal right here. That is, of course, not a good idea. We got a few signals going back and forward between the two modules. That is, of course, trace rotation, I think. That is what I was looking for. The inspection 81. I think that is what it reads. So now we know how old this one is. Let me try and flip it carefully down here. And that is, of course, the time base. And look at that. We got all 4 screws missing here on the top. And it also looks like it's not correctly assembled. So this tells me this unit is definitely not expected to be working. Probably all sorts of bad things is going to happen when I try and power this up. Ooh, oy, oy. What is that? Another little funny resistor that is hanging. And again, let me point out how important it is to do deep going visual inspections on all those flea market finds. You never know what you're gonna get. Here is the left side, the 2 inputs. Shield is like really easy to remove. Just bend it up a little bit and then flippity flop. And of course, just remove this little screw here for the ground that holds this part down here. And now we can see the 2 analog amplifier channels. Here's a fun thing to mention. Look at the 2 sides. They are exactly the same part number with the same holes for the different trimmers and whatnot. But of course, why would you spend a lot of money on 2 different parts when the same can do the same? I mean just 2 times. This is a good way to save money. So here's the time base and a lot of stuff involving high voltage. Oh yeah, look at that. There's of course also a mains transformer hidden right there. A toroid. That is interesting. You don't see that every day in oscilloscopes from this age. So mains transformer is from 79. They're probably handmade to this project from 79. What else can we see here? Voltage selection. Oh, some nice warm diodes. And another fuse is hidden right there. I kind of like the switches with all those sticking all the way here to the back, where exactly you want all this. So you're not transporting high voltages. So all this is pretty good. With this one, definitely tell me we have a power supply issue of some sort. So I keep finding all sorts of funny things on my visual inspection. And look at the corrosion right there and further down. I don't know, I can't get it to focus. Yes, here. Down there it is also really nasty. So this tells a little bit about how this unit was stored. So of course I don't expect to be able to repair this one. And the guys that sells these, they're already radio amateurs and skilled electrical experts. So, I mean, if they gave up on this one, I'm definitely not going to spend a million hours trying to repair this one. But I really need to document. Can you see this? 17 and 18. It's the yellow and the green wire. And then it goes all the way to the other board. And again, the red and orange also goes down to the other board again, but on the other side of the CRT. But we need to know exactly where to put these wires in case we poke everything apart. And it's not marked like that. It just says channel 1, channel 2, and then again channel 2 down there, and that is the yellow one that's down there. So, I mean, why couldn't they just write the colors or something like that? This is a little bit annoying. I cut away this resistor so it's not going to cause all sorts of shorts, because this is in the high voltage part of the circuit in the cathode system, and that will be the intensity and focus potentiometers, these two. And I don't know if you can see what they've been doing. They cut some tracks here to perform some measurements, and then they gave up. And on the solder points to here, a lot of measurements attempts, and the same on the other potentiometer. I can see those little dots. That is because they have been measuring around and trying to debug what is going on. And since intensity and focus, that's a high voltage cathode system, so I bet there is a problem with the high voltage in this unit, and I don't expect us to be able to see any kind of beam or anything like that. But I also see some other things that is a little bit depressing. Look at that trimmer right there. Is that some sort of a fungus, more or less? It's totally alive. I mean, this is not good. And this reveals a little bit the state of storage for many, many years. Way too damp. This is not so good. So let's just try and power this up and see what happens, right? So first, this is our on-off switch. I'm using the variable, and then let's just give it like 10 volts or something like that, just to see if this power on-off switch is working. And no response. That is a little bit interesting. I was hoping to see just a little milliamp. So that means let's give it a little bit more. Yeah, okay, we have a fuse problem, or something is disconnected. So this is interesting. This fuse is okay. Those switches, they're okay. This on-off switch also reacts normal. Why can't I see any kind of milliamp consumption at low voltage? Well, let's try and give it a little bit more and see. One more go. Let's move it like that. And it's not using, oh, here we go. 50 volts, and it's using half a watt. That is a little bit strange. 100 watts, and it's using 1.8. So that means we can easily crank it. Oh, here we go. 150 volts, and it's using 20 watts. Well, that is still normal. We got the lamp is on. I am at 200 volts, and it's using 30 watts. 220. And here we go, 37 watts. So we need some trigger, we need some auto trig, we need the position. And this is very close to what I expected. We probably don't have any high voltage. Let's turn on all the channels. While I watch this screen, I also carefully watch my power consumption, because if it's going up, beam finder. No. Nothing is. Well, it's very close to what I expected. I was able to find schematics for this unit, so briefly I had the idea I could maybe make this work, but I keep finding all sorts of really nasty things. If you look, let me try and move this wire a little bit, maybe we can see this. This capacitor exploded down there, and then there's a part of it that splashed up here. See, a little explosion. So that is of course why it's not working. Let's look a little bit at the power supply schematic, and this is a very classic oscilloscope power supply, and it's also done in 2 stages. So at the left we see the mains input transformer, and that is a toroid. Then we have a low voltage rectifier and a low voltage capacitor, and then the self-oscillating driver that drives the high voltage transformer. So it's just running at full duty cycle, full power output. And then we see in the middle, marked here, a Darlington transistor, and this is mounted at the rear heatsink. This one is the one that gives more or less voltage to that self-oscillating driver. And it's using a 22 volts input from the secondary side, and that is how it is voltage regulated and controlled. The high voltage for the cathode system is just a classic voltage Doppler rectifier, and its grid for brightness, its intensity, is capacitive coupled to a blanking circuit. Here is the switch mode converter for the high voltage part, that one here, and we got the push-pull transistor stage and the little trigger transformer. So this is actually a self-resonant oscillator that's driving the transformer, and in series with this we got some transistors controlling how much this is, how much power this system gets, and it's using the 22 volts from the secondary side of all the rectifiers. We will see some of them down. We don't see them that much, but they're down there, all the high voltage and all the low voltage regulators, and the 22 volt is used as a feedback system to control the drive. So that means our high voltage is regulated, so that's pretty good. And I keep finding those trimmers that's completely fungus. See, full of nasty fungus, and it's more or less all the trimmers of this brand. You can see that some of the bad ones really here in the middle of the picture. How nasty is that? So the entire unit here really smell of I don't know, wet dog with bad breath or something like that. There is just a nasty fungus wet feeling to this whole scope. And the fact that it was definitely attempted repaired, and on top of that we have all these annoying things with the connectors on the sides. We got the whole look of it. It's just not looking so nice and pretty anymore. You can see all the colors here. It's been in direct sunlight for way too many years, and everything is just rusty and corroded. And I mean, I'm just going to look a little bit more about what is going on, what is the status of this one, so I know exactly where we are at. And then it's just gonna go back to my storage as it is for a whatever is going to happen to this one in the future. Maybe donor parts for another one. Maybe I can swap a board if I get another one day. Well, we'll see what happens, but at least this video is what is the status of this thing so far. I'm sorry I'm not going to spend that many more hours on this one and making this video super long and boring, because I'm not going to get this one up and running with all those problems. Sorry, and bye bye.